I'm going to use my three colors. Side, side, side. We call it SSS because spelling out the word side is just too much work for mathematicians. We got math to do. We don't have time to spell out the word side. We just call it SSS, side, side, side. Okay, those are the three colors I'm going to use. You can use your three colors however you want. I'd use three colors that show up when you draw with them. Alright, now we're going to open that up, side, side, side. We're going to be doing it with these pictures here. So we're going to name the sides that are congruent. So if I have AM, side AM is going to be congruent to side KP. So I'm going to mark those with a tick mark, and then on my little flap here is where I'm writing that information because I'm going to write the three parts that are congruent. Alright, and then we have MT. I'm going to do that 2 tick marks. Is going to be congruent to EP. Alright, and then we have our last side here, which is AT. I'm going to do 3 tick marks there. Is congruent to KE. Alright, now if we have all 3 sides that are congruent, there's no other way that these triangles can be put together without creating congruent angles. This angle M will have to be the same as angle P. Okay, so if we know all 3 sides are congruent, we can now say all 3 angles are also congruent, and we can just automatically say these triangles are the same. So we're going to write a triangle congruence statement. I'm going to write it over on this side, just underneath it. So triangle. The first one that we name doesn't matter the order we name it. We can go in any order we want. So we can do triangle AMT, ATM, MTA. Samaya, what do you want this first one to go in? Name those three spots in any order you want. AMT. Okay, so AMT. Now the second one matters. We have to have it match. So AM is our blue, or our 1 tick mark. MT goes 2 tick marks, and then we end with that 3. So it has to go 1, 2, and then 3. So for our second one, what's going to match with A? K. And then P, and then E. Good. Wonderful, amazing. You guys did it. Alright, that's side, side, side. So go ahead and once you have that done, you can flip that down. We're going to go on to the next one. We're going to go to side, angle, side. We're going to go below. Alright, so going to go underneath. We're going to do side, angle, side. So again, we are really famous mathematicians. We're really smart. We're so smart, we just call this S, A, S. Alright, so for side, angle, side, the way that this one works is that we have the side, and then the angle is called the included angle. So we're going to start with our two sides that are congruent. So we're going to open up this flap. I'm going to use red and green since those are the two colors I used here. I'm going to use A for blue for my angle. But we're going to start with two sides that are congruent. So I'm going to start with like NR is going to be congruent to CW. I'm going to write that over here. My NR side is congruent to CW. Okay, then I have another side. I'm going to leave a little bit of a space here. I'm going to write my third side, or my second side down below. And I'm going to do RG. Leave a little space in between there because it has to go in the middle. RG is congruent to CH. Okay, now those are my two sides. And the angle has to come in between the side. It's the included angle. So it's where those two sides come together. So as I look at where these two sides come together, I have NR and RG. What angle connects both those sides? Yeah, angle R. So angle R is going to be congruent to angle C. We're going to put that in the middle here because it's called the included angle. So it's right in between where those two sides come together. It's the included angle. Yeah. I don't know if they'll switch you out, but yeah.
Okay.
So you'll probably still come here. Check your Skyward. Good job. Alright, so again we're going to write those triangles that are congruent. We'll write a triangle statement. First one doesn't matter the order it goes in. Kaden, what do you want our first triangle to be?
NRG.
What? NRG is congruent to triangle. So now we have to kind of match up what we think goes with NRG. We know for sure what goes with R. That one's easy for me. A lot of people still writing, sorry. Pausing for a moment. So what goes with R? C. So I'm going to put that in the middle. So I know R and C go together. So I like to leave like a little space there. I like to think, okay, there's a little space. We're getting there. All right. And then what would go with N when I go to NR? Is that going to be HC or WC? WC, good. So WC and then H. Okay, so as we work our way through, we're figuring out which parts go together, which parts don't go together. First congruent statement can go in whatever order we want. Second congruent statement needs to match. Alright, we're going to fold that one up when you're done, and then we're actually going to go back up to the top. We'll come back to hypotenuse leg at the end. That one's a very special one. Okay, so I'm going to fold that one. Alright, going to go up to this angle side. Yep, so we say AAS, mostly because when we do proofs, we don't want to have to write out that whole theorem. It takes way too long to write out angle side. So why do that if we can just write AAS? Angle side. Alright, sometimes when we work with these triangles, our triangles have overlapping parts, and this is where we really like to use that reflexive property, and we like to use our vertical angles property is with these triangles. So as we open up this one, and we look at this, we have two angles that are going to be congruent, and one side that's congruent. What side do both those triangles have in common? Yeah, dy. So that's going to be our side, is that dy is congruent to dy. I like to always do two tick marks because it always looks silly to me to always put one there. Okay, so we're going to have two angles, angle, and then our side is dy is congruent to dy. And we knew that it's not always going to be marked. We could have said that and seen it without having that marking there because it's on both triangles. So this is that reflexive property. That was the one that we said looking in the mirror. We know like 1 is equal to 1. Angle A is congruent to angle A. We know that that side is going to be congruent to itself because it's the same side in both ways. And that's our reflexive property. If I cut those two triangles apart, that side that they share would be the same length because it's the same side. Alright, we have two other angles that we do need to do because it's angle side. So one angle we're going to say is the same as angle J is congruent to angle E. And now for another angle, our second angle, this time it's not going to be quite as easy as to note or to show where they are. We're going to have this angle up here by D. So we'll use two arcs there. Okay, but that actually goes with this angle down by Y. Now for these angles, we can't just say angle D. If I say angle D, why can't I just say, where is angle D? Yeah. Good, there's two angles. There's this one below, there's the one above, and then there's that whole angle. So if we can't just use one letter to show exactly which angle it is, how many letters do we need? 3. Yeah, we need 3 letters. So we're going to say angle. For this one, we have to go 3 letters. It's like we're going to outline it. D is my vertex, so that's going to go in the middle. So we're going to say J, D, Y. Is congruent. Now the second one, again, we have to use 3 letters. What letter do we want to be the middle letter? Y. Good. That's a vertex. So y needs to go in the middle of this one. So who's got that one for me? Sure, EYD. We could have also done DYE. But that y needs to be in the middle. So now we have two angles and a side. When I look at this, I'm going to cover up one triangle real quick. Is this side the included side? Is it in between the two angles we marked? It's in between these two angles? No. So this one with angle, side, it's that the angles connect, and then the side is on one of the other parts that doesn't connect the angles. So that's the difference between angle, side. And our next one should be angle, side, angle. But let's write our triangle congruent statement. So triangle. First triangle, doesn't matter the order we put it in. Tommy, do you want to put a triangle out there for us? DJY is congruent to triangle. So now for DJY, we want to match what goes with that second triangle. So what's going to match with D on this opposite triangle? D doesn't match with D this time. D actually matches with Y. What matches with J? E. And then D. Because these ones match their opposite. So D doesn't actually match with D this time. D matches with Y. Yeah, they could be. If we knew that they were parallel. Now we can say they're parallel because they're congruent. It's a converse. Alright. Once you're done with that one, go ahead and flip that flap. Flip that flap, flap that flip. We have one more of these four. These top four are probably the most popular ones. And then we have one extra one, hypotenuse leg, which we just kind of throw in there because it's important, but it's kind of silly. Alright, so I'm going to throw that one back down. Make sure you got it. Cool. Alright, last one here that's the top four, the main four that we use all the time is angle, side, angle. So we have angle, side, angle. Now you might be looking at this, and as you look at this, you're like, okay, well there's two A's and an S. This one also has two A's and an S. Where that S is located is really important. This one, the S is on after the angles. This time, the S is in between the angles. So it has to be the side that connects the angles as we look at it. Okay? So first off, when we take a look at our picture here, there's one angle that might not be marked that we can assume is congruent. Which angle, based on this picture, do we know is congruent based on the picture? Yeah, the angle's at B. I can't just say angle B, but the angle's at B. Good, so I have this angle is congruent to this angle. But we can't just say B because there's two different angles. Technically, there's four angles there. So we need to use three letters, and we want B to be the vertex. So we're going to say angle good, we could do LBQ. Is congruent, and when we do these angles, we always want to think that we're tracing the angles. We want B now to be in the middle of our next one. Doesn't matter the order. We're not saying, it's not like triangles where it has to match. L doesn't have to match with the other part, but the B does have to come in the middle. So we could say X, B, F. Yep. Okay. And maybe write in there that that's vertical angles. So when you're doing your homework today, these vertical angles might not be marked, and it might say, okay, which theorem are you using? And it might be angle, side, angle. It might be side, angle, side. It might be any of those, but since they're not marked, some students are like, well, they didn't mark that they're congruent. That's something we don't have to mark. At this point in our geometry careers, we know vertical angles are congruent. We should be able to put those marks in our head as soon as we see that. Okay, so now I have angle, side, angle. So the side I'm going to pick this time is going to be really important. We're going to say BX is congruent to QB. QB is congruent to BX or XB. And the reason why that side is really important is because that side is going to connect us to the next angle. Because it's angle, side, angle. This is called the included side. Because it connects the angles. So if I start at B, and then I take BQ, I take that side, which angle does that automatically land me at? Angle Q or angle L? If I go B, and I go to my side, I'd end up at angle Q. And angle Q would have to be congruent to angle X. Alright, so then we say triangle. First triangle, doesn't matter the order we put it in. Huda, do you want to put a triangle out there for us? You're not Huda. PQL. BQL? BQL. Sorry, I heard P. BQL is congruent to triangle. So if we go B to Q up to L, what's this next one going to have to be to match? Good, BXF. This time our B's match. Those angles are the same around B, so B's come in the same position, in that first position. Good. Alright, I'm going to do a quick recap here. So I have angle, side, angle, and then angle, angle, side. Do we see how this red side is in between the blue and the green there? Okay. Right here, if I look at my green and my red, my angles, this side is on the outside. It's not in between those sides. So if you're struggling between those two, usually I cover up one triangle and I look at only one triangle at a time. And I say, is the side connecting them? Or is the side on the outside? If the side's on the outside, then it'd be angle, angle, side. If the side connects them, like this one, it's in between right in between those two angles, then it's angle, side, angle. Okay? All right, last theorem, we have hypotenuse, leg. Hypotenuse, leg. HL. Okay, so a couple of things about hypotenuse leg. Whoops, you can't see that. Hypotenuse leg. Stop being weird. Is when do we see a hypotenuse and a leg? What kind of triangles are we working with? Right. So this is right triangles only. This only works with right triangles. So I'm going to use my third color that I didn't use on the front. I'm going to show that little box that we know that this is a right triangle. It only works with right triangles. Alright, so the hypotenuse, does anyone remember where is the hypotenuse located in a right triangle? It's okay if we don't. It's been a while since we've talked about it. Hypotenuse is always right across from the 90-degree angle. So this is going to be our hypotenuse. And hypotenuse is this crazy word. Again, it's Latin. You can thank the Greeks for that. Hypotenuse. And we call these other two parts the legs. Doesn't matter. So I have leg and leg. Two legs, one hypotenuse.
You always think that hypotenuse is the longest length on the right angle triangle.
Alright, so if I start with that hypotenuse, I'm going to say that CZ, that's the hypotenuse of this right triangle, has to be congruent to the hypotenuse of the other right triangle. So in this triangle here, which one is the hypotenuse? Is it going to be UT, TK, or KU? KU. Good. It's across from that 90 degree. And then it doesn't matter which leg, as long as one of the legs is congruent. It could be the shorter leg or the medium-sized leg. Doesn't matter. We can pick. Which one do you guys want? Do you want CW or WZ? WZ. Okay. So WZ, one of the legs is congruent to the other leg. And WZ in this case would match up with TK. Alright, so last congruent statement here that we're going to do, and then we have a couple tricksters that we need to talk about. Alright, that's triangle. First triangle, we can go in any order we want. Jason, do you want to do a triangle for us? No, you don't? Who do you want to do the triangle? Pick someone, and they have to do it. Haha. Hey Zeus, you gotta do it. Triangle what? Just name the three letters any order you want. CWZ. Beautiful. Amazing. Good job, Jesus. CWZ will be congruent to triangle. Now this one, it's really important we match. So CW and then to Z. W is our 90 degrees, so that has to match with T, has to match with W, so that goes in the middle. So is it going to be KTU or UTK? Good, because CW is kind of that shorter one. It's the one not marked, so UTK. All right, and on the front of that one, we wrote HL for hypotenuse leg. All right, last one is tricksters. All right, the tricksters are ones that when we look at the picture, we're like, oh, that should work. But the answer is no. It is not a theorem. And our brain is like, but we can do it with letters. And so far, we've done things with letters. And we're like, no, doesn't work. So tricksters are things that do not work. So something that does not work is angle, angle, angle. If all three angles are congruent, we cannot say that those triangles are congruent. That is not a theorem. Angle, angle, angle does not work. So I'm going to do that A, and then I'm going to lightly, lightly, lightly cross it out, showing it does not work. Okay. The other one that does not work that a lot of us like to think works is side-side angle. Okay, again, side-side angle will not make congruent triangles every time. Does not work. And the way I remember that is because side-side angle really spells ass. I can't do ass in math, you guys. Doesn't work. No ass. Okay? So those are our tricksters. If you see angle, 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 or side-side angle, also known as ass, you can't do it. Alright? Alright, so go ahead and you're going to glue this into your notes. We're going to be doing this with proofs tomorrow. Today is just going to be about identifying which theorem you can use. Looking at it, deciding. Tomorrow we're going to actually do this with proofs. If you want to label it, you can label it 4-4 and 4-5 congruent triangle theorems. If that makes your heart happy, to make sure that you have a label on it, because everything needs a label. If you don't care, that's your choice. But this is 4-4 and 4-5, which is congruent triangle theorems. And then you can go ahead and get that glued in, and then once you have that glued in and you have it